On tonight's homework, we're doing some problem solving involving sequences. Problem number 5 says, May hosted a party. She had 50 party favors to give away, and she gave 3 party favors to each of her guests as they arrived at the party. Let n be a positive integer, and let f of n denote the number of party favors that May had before the nth guest arrived. There's a key word here, before. It's going to affect everything, so let me underline that. What is the formula for f of n? So I think it's always good to create a table to show the sequence, and I'll make this table, most of the tables we did yesterday were horizontal. I'll make a vertical table just so we can see that it works equally well in either format. So I have n, which would be the nth position in the sequence. So n equals 1, n equals 2, n equals 3, and then we have f of n, the number of favors in terms of n, and it says the number of party favors May has will be we'll think about the number of party favors before the nth guest arrived. So before the first guest arrived, how many party favors did May have? Before the first guest arrived, she had all 50 party favors. So f of n, or the term in this sequence, would be 50 when n is equal to 1. Before the second guest arrived, she would have given 3 party favors to the first guest. And so before the second guest arrived, she would have had 50 minus 3, or 47 party favors. Before the third guest arrived, she would have given away 3 more, or she would have given away 3 2 times, so for a total of 6 would have been given away, which means she would have 44 party favors left. In order to write the rule, we have to write the rule in terms of n for any guest. What would be the number of party favors? How can we write an algebraic expression to represent the number of party favors for the nth guest? Try to do that during the pause, and then come back and see how you did.
Paused.
There's a couple different ways to write this rule. This is clearly an arithmetic sequence because we are, from one term to the next, we're subtracting 3 or adding a negative 3 for each term after, each successive term we're adding negative 3 or subtracting 3. So we could start our rule f of n by writing negative 3 as the coefficient of the variable term, negative 3n, and then adjusting. And when I say adjusting, sometimes this seems really, this is one of these things that seems really easy to me, but when you first start doing it, I know it's not as easy as I think it is. So let me be very explicit here. When n equals 1, f of 1 equals negative 3 multiplied by 1. So the first term, based on our rule so far, would just be negative 3. But we know it's 50. So what must I be adding to this rule to get 50? I have to add 3 just to get 0. I have to add 50 more to get 50, so I have to add 53 to this rule. So if you're going to write your rule this way, you would add a constant term of 53 to make it work out. We can check it for n equals 2. Negative 3 multiplied by 2 would be negative 6. And negative 6 plus 53 would equal 47. The reason I say if you're going to write it this way is because there's another way to write it which might be better in this case. If you did problem number 4 this way, you probably noticed that you had a constant term of 463. There's a hint for problem number 4. If you use this method, you'd get a constant term of 463, which is relatable to the problem because the novel that Hannah's reading is 463 pages long. This constant term in this problem is not as relatable because May never has 53 party favors. She has 50 party favors. So let's try to write a rule starting with the number of party favors she has. Let's just start with 50. We know that we're going to be subtracting some variable term, and we know that the coefficient of the variable term is going to be 3. But it's not minus 3n because we know that, let's just pick like when n equals 2, for example. She hasn't, if we did 3n, it would be 3 times 2. We'd be subtracting 6 from 50. But we know by the time we get to the second term, we're only subtracting 3. So we don't want to multiply this 3 by n. We want to multiply it by 1 less than n, or n minus 1. If you do n minus 1, let's look at the first term. What is n minus 1 when n is 1? 1 minus 1 is 0. So you're subtracting 3 multiplied by 0, which is 0. If you subtract 0 from 50, you have 50. So this form of the equation works for any position in the sequence, and it's also more relatable to the story of the problem because we're starting with the 50 party favors. They're both equivalent. Let me try to convince you of that down here. If I take this second version of the equation that we wrote, and I distribute this, well, let me first use a definition of subtraction. 50 minus 3 times n minus 1 is the same as 50 plus negative 3. Subtracting is the same as adding the opposite. If I then distribute this negative 3 to both terms inside the parentheses, I get f of n is equal to 50 plus negative 3n plus negative 3 times negative 1 is just 3. So if you combine like terms now, combine the wholes, you get 53 plus a negative 3n, which is the same, that's the same as this first rule that we came up with, negative 3n plus 53. So they're equivalent. It's just that this second rule is more relatable to the problem because the constant term is the same as the number of party favors May started with.